Welcome back. Today we're going to talk about resources, specifically human resources in the form of natural capital. A couple of questions I want you to focus on during the lecture today. The first question, what is the difference between natural capital and natural income? The second question, explain how resource use can be either sustainable or unsustainable. So as we look at this today, some of these terms, specifically terms like capital, income, renewable, non-renewable, and replenishable are going to sound familiar, but they might be used in a slightly different context. So be sure to pay careful attention to the differences from what you traditionally might think of their usage. First, when we talk about non-renewable resources, these are items that are being used up, and because they are a fossil fuel, they come from something that was processed over millions of years, and these things are being used quicker than what they can actually be replaced, which makes them non-renewable. A renewable resource means that certain things that are actually going to be produced out in nature, things like crops, things that we studied in class, forests, possibly something like fish, these items are all considered renewable as long as the speed at which we harvest them does not exceed the speed at which they can replace themselves. Replenishable often focuses on the sun as the energy source to recharge a system or to recharge a resource. Now, some examples of that could include things like groundwater, possibly a lake, or even something like ozone. Groundwater and lakes are obviously part of the water cycle, which means that the sun is the main driving source of energy for that. But even in the atmosphere, a lot of the particles and a lot of the movement going on in the atmosphere, things that get moved around as wind or other chemical reactions that happen are largely dependent on the sun. Now, of these resources, we can often classify them as either something that humans use as a good or a service or as both. So, for example, crops are often used as a form of goods for humans, something that we can possibly sell or even eat, something that we have as a direct benefit. Forests are one of those examples that could be qualified as goods or services. As goods, we can do things like get timber from that, which is a useful resource for building, but it can also be financially beneficial to sell that. As a service, a forest might help to control air quality, but it also could help in things like erosion prevention, where it's holding the soil in place. So how do we classify these things as natural capital or natural income? Now, if we took a look at a bank account, if I look into my bank account, traditionally, I would say my capital is the amount of money I have in there. So if I had $10,000 in my bank account, that's going to be my capital. It's the amount of money that I have, right? And my income, if my next month's paycheck was for $1,500, then that's going to be added. So this is my income for the month, and if we add these two things together, we have a new capital in the bank account of $11,500. So how does this apply to nature? Well, I think an easy one we can look at is if we have a tract of land. Let's say we have this piece of land here, and on this land, let's divide it up to make this kind of easy. We have a few different sections. If this is a forest on this land, this is our total natural capital. So the total here is the capital. If this represents something like a crop, if I use up this much of it, that means that's going to be what's being taken away from my capital. So I've subtracted out 1/4 of my crop. The income is what can be added to this. So my natural income is if this much of that crop can regrow in a given amount of time, then this is going to be my income. In this case, we could say that this is a sustainable usage because the amount that is being used is equal to the amount being grown. So if we apply that into a system, now we can see lots of different things in the system that we can apply to that situation. So a few cases, we might say that this lake here is a natural resource. So this is a replenishable resource. How do we know it's replenishable? Well, because this is being recharged by the sun. All the water that comes in here is going to be due to evaporation going up, and once clouds are formed, the rain that brings it back in is going to refill this space. So the sun's what's powering this water cycle to happen, and that makes this a replenishable resource. Now, how can we determine if it's being used sustainably? Well, if this farm back here is going to pump water out, so if they're taking water out of the lake in order to farm something, if they take out more water and there's less water going back into the system, then this is going to be an unsustainable usage of this resource. But we have another example right over here of natural capital. We have this forest, and this we could consider a renewable resource. Now, let's say somebody owns this forest and they decide that they want to cut down 3 of these big trees in the front here. Now, as long as 3 new trees can grow during the time or within a normal time frame of what those trees were cut down, we could say that this is a sustainable example. If we cut down 3 and 3 grow back, we're at a balance. So as long as we're either growing more back or we're replacing our resource quicker than we're using it, we can say something is sustainable. So in terms of looking at sustainable yield, there's some real basic calculations we can apply to determine if a system is being used sustainably or not. There's 2 equations we can look at. They basically say the same thing. In this case, we're looking at the amount in a system, the total biomass that's actually grown divided by its energy at a later time. So this is often what we could think of as what's going to be regrown within a system minus what's being harvested. And again, this is simply in terms of something that's being grown, harvested out of that system. So let's look at a quick example of something maybe that could be harvested. So to determine the sustainable yield of a place, let's say you have a tract of land, and on that land you have about 1,000 trees. Okay, so let's make this easy. Let's divide it up into a couple of sections, and each of these sections is going to represent 200 trees. Okay, so 200 trees in each section. If in 1 year I harvest 400 trees, and my regrowth rate in that forest is 200 trees, then I'm going to remove 400 of the trees, and I'm going to add an additional 200 trees of regrowth. So again, this is my income here. The total here is my capital, and I'm left with a net difference of negative 200 trees. So it would only take about 5 years until this entire forest is gone if I'm removing 200 trees more per year than I can actually fill into that system. Immigration versus death, same thing. Let's say we have a system where I come from, hunting is pretty common. So if you're looking at a sustainable yield, a group that might be trying to manage a population of deer in an area. So let's say there's a population of deer in this area, and let's add a bunch of deer into the system. Okay, let's say there's one more deer into that system. Now, if we're trying to figure out the sustainable yield of hunting within the system, let's say each of these deer actually represents 100 deer. That way it's a little easier to put some normal numbers onto this. So let's say if you were trying to determine how many hunting licenses to give away a year, you would want to look at the growth rate within that area. So let's say annually about 100 deer can be replaced annually. So if you're trying to determine the number of deer that could be hunted, you would want to either keep it at a sustainable level, or you would want to make sure that the number can increase. So if you're going to give out hunting licenses, if you give out 100 hunting licenses for the deer, that means you are going to allow 100 deer to be removed, but at the same time, 100 more deer can actually be replaced into that system, which gives us a net loss of 0, which means we're going to keep a stable population, and this would be a more sustainable system. Overall, thanks for tuning in today. Again, if you need a chance, go back, rewatch the video. Hope you enjoy. Keep on learning.